Hello, everyone. Let me see. We're doing this live, so who knows what's going to happen. So here I am in my basement in Georgia, and today's talk, let me see if I can switch over here because I was having difficulty with, no, they won't let me do that. So we're going to have to do this the old-fashioned way. So today's talk is patterns and the nature of software development. One of the great things about having been around since the beginning of time is that I get to talk about things I learned about 30 years ago as if they were new, because quite often they are new to folks who've not been around for 30 years. And so the idea about patterns came at me again just a few weeks ago, when there was a discussion on Twitter as to whether the patterns that are written about in the Gang of Four book are still relevant. And so that's really my primary talking point here today is, are patterns still relevant to us? Uh-oh, I've just been attacked by a cat. In a moment, you're likely to have a cat show up on your screen somewhere. There's, you got a tail. That's live TV, folks, live TV. And so this brings us to the design patterns book written by the so-called Gang of Four, the best-selling software engineering book of all time. It's a book that for a while every software developer, certainly in the object space, had on their bookshelf. It was something we talked about, something we read, although it's kind of dry. It doesn't really have much of a plot. And so it introduced the idea of patterns to us. Now, patterns, as it turns out, go back quite a bit longer than this. Let me see if I can fix that. Oscar, get out of the way. You know, live TV. The idea of patterns started back actually in architecture. A fellow by the name of Christopher Alexander wrote a book back in the late 1980s called The Timeless Way of Building, which used the idea that there are some problems that show up time and time again, and that over the years we have discovered ways of solving them. And he took these and turned them into what he called patterns. A very common one is when you're designing a building, how will people know where the door is? How will you know how to get into the building? And so there are clues that builders and architects build into structures to let us know where we're supposed to go. One of the common features is the sidewalk leads to the entrance. And so one of the patterns is you let people know that this is the entrance by having a sidewalk go to it. Sometimes they build structures around the entryway so that you focus on that spot and know that's how you get in. I've had situations where I'm wandering around a building in a large city trying to figure out how you get into it because they violated these patterns. And so patterns are a way of communicating an idea that is known to work over time. And so we brought that idea into software, that there are problems that occur over and over again, and that we want to look at how those problems are normally solved so that when somebody sees this solution, they say, oh, this is the problem they are trying to solve. Or when they see a problem, they have, here is how we generally solve that kind of problem. This idea was brought into software by a group of folks starting out in Portland, Oregon, called the Hillside Patterns Group. It was founded by Kent Beck and Grady Booch, two great names in software engineering. Kent, it turns out, was a former architecture student, so he found these ideas and brought them into this group of folks he hung out with in Oregon. It's called the Hillside Group because they used to meet on the hillside behind Ward Cunningham's house. They're still around today. They still publish patterns. They still put on conferences every year. Take a look at hillside.net and see what they're doing. There are conferences in the United States and in Europe. They go by the rather weird name of PLOP, Pattern Language of Programming. It's still an active group, still talking about these things. So when we're talking about patterns, what do we really mean? Well, an example might be handy right about now. And so one of the things I often see in code is something that looks sort of like this. Some method starting with checking to see if a parameter, some data passed into it, is actually there or whether it is a null. Some of you may write code that looks like this all the time. Many of us see this code all over the place. And what we're seeing here is a pattern. We're unsure whether the parameter, whether the data element being passed to us has something we can actually use in it, or is it a null, and therefore I have to figure out how to protect myself from that. One of the common approaches is to do exactly what we see here, that we just check to see if it's null, and then we do whatever it is we want to do. There are other ways of dealing with that. And one of the ways that the Gang of Four book describes is something called the null pattern, which is that when did a cat just go flying by? When you see a situation where a null could come into existence, come into your system, you want to replace that null with an object of the same type as you would expect, but contains default behavior. And so here we have a simple little example where we have within this object called ball, two strategy objects. Strategy object is another well-known pattern. And if we don't have the strategy pattern, we don't have the particular strategy, we immediately replace it with this null strategy, one that will allow us to talk to it as if it was the object we intended, but it will behave in a way that is what we would do knowing that we didn't really have it. Another example of this is that many years ago when we were doing the payroll project at Chrysler, we had situations where some employees did not have addresses for some reason. And so what we did was we replaced them with a null address object. And the null object, address object caused any mail we sent to them to just come back to the payroll department. It had the payroll department defaulted as its address. We could search for any instances of those and see who did not have a address. We could have, when we went to print a label for them, we could cause a report to be generated because this one was not a real address. And so you take all of that default behavior and instead of spreading around your application, you put it all in one place into this null object. And so this way of acting causes us to think about the problem in a different sort of way. And so I recommend that you go back and take a look at these patterns and see which one of those makes sense to us, makes sense to you in your particular context. There have been other catalogs of other kinds of patterns, and let's just take a quick look at those. When it comes to code level patterns, one of the places I always like to look is Kent Beck's book called Implementation Patterns. This is an interesting book which goes through many of the issues that come up in common software coding and talks about the forces that the author Kent Beck sees and how he responds to those forces. Here, Kent is not saying this is what you should do. He is simply saying, here's the discussion you should have. And this will come back here in a few minutes here a little bit later in this talk. So this book focused primarily on Java, but applicable to almost any language, goes through dozens of scenarios, talking about what happens to cause us to want to write code this way, what things we should think about, what are the forces that might be acting upon us, and therefore how we should respond to those things. It's a very good resource for those of us who are writing code on a fairly frequent basis. It's a tool we should use when it comes to thinking about how we should act as a team working together to solve problems as a team. There are other places where patterns come into play. Another of our colleagues from the old Chrysler XPC3 project, Martin Fowler, has written a couple interesting books about patterns. At the architecture level, he's written Patterns of Enterprise Application Architecture. If you are an architect, this is an incredible resource to look at. Here are problems that often come up when architecting solutions to problems, and well-known solutions to that kind of problem. What kind of forces should we be looking at? What things would influence us to do this one way or another? If you are on a team and you're being exposed to architecture and architectural decisions perhaps made by somebody else, and you'd like to have a better discussion with them about why they're making these decisions and what kinds of decisions should be made in particular situations, here's another great book to look at them. Look at this book and see what things other people in the architecture world have done in this situation. This is a place to go to understand what MVC is really supposed to be, as opposed to the things you find in frameworks claiming to be MVC, like Spring and other such things. An interesting book, a place you should look for these things to be a more complete developer. If we're working in business applications, solving problems for our customers, Martin has written an interesting book about that called called Analysis Patterns. Analysis Patterns looks at common business problems and catalogs common solutions that we should look at when dealing with them. If you're dealing with business applications that require things like accounts, well, Martin has devised a very simple system for accounting and can be used almost as a blueprint to how to build a system that has accounting at its base. If you're dealing with multiple currencies, there are descriptions in this book about how to go about building objects within our systems that can handle multiple currencies and how to transition from currency A to currency B, how to move from euros to yen and capture that information. And so there's very interesting and detailed ideas about how to deal with those things. As a developer, as a business analyst, these solutions are ones that you should have at hand, and this book is a really great place to do that. As a developer, one of the issues we often have is we now discover we've built a system, built some piece of code in a particular way. And upon reflection, we see that perhaps was not the way we should have done it. The common tool for doing that is called refactoring, the changing, the improving of an existing piece of code without changing its external behavior, refactoring. One of the great books that help us in that is something by a guy named Josh Karyevsky, who's written a lovely book called Refactoring Two Patterns, which is how do I get from where I am today to the pattern I want. An interesting thing about Josh's book about this is that you don't have to go all the way to the fully envisioned pattern that you would find in the Gang of Four book. You might only need part of that solution. And one of the great things about Josh's book is it talks about how you can go down the path to a particular implementation of a pattern, but stop when you have enough. because often we don't need to go to the full implementation of it. We just go far enough to get the benefit we need. And that's a rather interesting way of approaching these things. Now, why am I talking about this? Other than I have 20 minutes to fill for Hugo. Well, one of the things that makes us a team is that we have a common mindset. We solve problems the same sort of way. And so I am pointing out these things to you because looking at these books, looking at these ideas called patterns, and discussing them within our team, looking at the problems we have, applying these patterns in a consistent, team-based way actually cause you to be more of a team. A good team will solve a problem the same way, regardless of who the developers actually solving that problem are. And so we want to develop a common style, a common way of solving these problems. We must do that mindfully. We should sit down and talk about how we're going to deal with a particular situation. Maybe when that situation comes up, perhaps speculatively by looking at something in one of these books and saying, I know we're going to be doing something like this. How much of this idea should we use for it? We want to be able to come together and make decisions about how we're going to do things. Sometimes we do that beforehand. Sometimes we do it in retrospective afterward. We build something and we say, is that how we should have done it? How can we remediate it back to where it should be? Sometimes we say, here's a problem in front of us. What solutions type should I, the programmer involved, take on so that we do what all of us wish we had done? Now, not only do patterns work at that code level, at the architecture level, they also work at the team level. There are decisions we must make as a team about how we will deal with things, about how we will work in the things that Chris just talked about, and the chaos that comes from working together with other people. And so having patterns in their hand about how we work together, how we build a working agreement that allow us to work together and be functional team as opposed to just a random collection running around trying to accomplish a problem without really a common mindset. And so, yes, I believe these patterns are still very, very relevant to us. Even though some of them perhaps were not relevant 30 years ago and may still not be relevant today, I can think of a few in the Gang of Four book that nobody ever does. But most of them are things we see. Most of them are things we see quite often. And knowing that there is a way that has been discovered and used over time with success should help us as developers build better systems. It gives us a place to talk about, here is a thing we want to do. How should we go about doing it? Much of what we do in the Agile world can be described as patterns, a common solution to a problem within a particular context. And so, yes, these are still relevant to us. And you may not have been very exposed to them over time, but use this as a wake-up call to say, go off and let's look at the things we do. Let's look to see if there are well-known ways of dealing with these problems at the implementation level, at the architecture level, at the design level, at the team level. And look at the patterns out there and see which ones are relevant to us, see which ones we need to reshape to meet us. So that is mostly what I came here to talk about today. Thank you for your attention.